Page 3 of our notes goes over ionic naming. So this is still the same kinds of bonds that we've been doing. So I'm going to use the same colors I have been using in previous pages, where the first thing is going to be a metal. And the metal has a positive charge. We call that a cation. And the second thing is usually your nonmetal. And that will have a negative charge. So I like to give students, for the types of bonds that we've done so far, which are just basic, we call it monatomic, meaning just one atom, ionic compounds, where it has one metal and one nonmetal. I like to give students the format, basically, of we're going to name the metal exactly what it is. And then the second part of the name is going to be nonmetal IDE. So we're changing the ending of whatever nonmetal you have to IDE. We'll use just the root of whatever the nonmetal's name is, and if you're not sure about the root, it will come with practice. It really is just shortening the name of that element to make it sound better. So when we're naming monatomic ionic compounds, we follow the convention metal+nonmetal-ide. And this is the reason that when you've heard of different compounds, like out in the wild, a lot of you probably before this class have heard of sodium chloride, IDE, but then when you look at your periodic table, you're like, well, chlorine has INE, and that doesn't really make sense. That's because it's been named correctly as chloride. So when you name this, you name the cation first and the anion second, so it's just the same way that the compound is always written. Remember, we start with the positive one every time. You're going to put the metal cation using the element name. So, for example, if you have cesium with a whatever plus charge, you're just going to call it cesium. And then the nonmetal anion, take the name from the root of the element. So the root of the element, I'm going to underline that, plus the suffix IDE. And then the example that's given here is one that I already just mentioned, chlorine. So Cl on your periodic table, if you look it up, it's chlorine, but the anion name is going to be chloride. You good? And then O2, what do we call that element? What is O? Oxygen. Instead of calling it oxygenide, we just cut off the oxygen part and call it oxide. So OX would be the root of that element. So when we name these, we name the metal exactly how it is on your periodic table. So let's try example 1 together, SR. So SR is right here. The name is called strontium. If you don't know how to pronounce it, you should at least be able to just copy the letters. So when you're writing these names, please make sure that you spell them correctly. If you can't read your periodic table because it's too small, let me know. I'll get you a bigger one. But strontium is the first name. Since that is my metal, I don't change anything about that. I'm not putting an ending on it. I'm just using exactly what that metal's name is. And then it's bonded to I. So I'd look up I on my periodic table. What's that? Iodine is the name of the nonmetal by itself, but we're going to take just the root of that, so iodide, and then we change the ending to IDE. So instead of iodine, it becomes iodide. Make sense? So then my nonmetal part would be IODIDE. We can be a little bit flexible with this, but what I want to see is that you tried to take the root of the element. It might not be super clear every single time where you're cutting that off, but you should know that saying iodinide sounds really weird and clumpy. Number 2, we have M, G, and S. So look up the element Mg on our periodic table, and that is what? Magnesium. And the second part of this compound is S, which is sulfur. But instead of writing sulfur, we're going to change that. Since it's my nonmetal, we're going to change the ending to IDE. So instead of sulfur, we're going to call it sulfide. Good. It's usually around this point in the semester where students start to conflate things that they maybe have heard in real life with things that they're seeing on paper. Note that I did this on purpose. It is IDE. There is such a thing as sulfite, ITE. There is such a thing as sulfate, ATE. They're all spelled differently on purpose because they're different things. So in this case, we are using IDE to show that it is sulfur as part of this ionic compound. And then let's do an example for Na2O. What is my metal in this case?
Sodium.
Do I change the ending at all? Perfect. Sodium. And then my nonmetal is oxygen, and we've already seen oxygen as oxide. Perfect. Then we have Li3P. My metal is called lithium, so use the whole name. And then P is what nonmetal? Phosphorus. And so if I were to just tack on IDE to the end, that would be phosphoricide. That sounds really weird. So what about phosphoride is what a lot of students try to write. Phosphorus is kind of funky because it's got so many syllables and letters in there. So we just call it phosphide. Perfect. But notice in each of these you see IDE, 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 IDE. So that's why they follow the metal, non-metal-ide format. And then the last two examples we'll do are going to be going the opposite direction, where I give you the name and you need to figure out what the formula is. So this is a review from what we did last week in class. If I have strontium chloride, my metal is obviously strontium. You should hopefully recognize that because that's a name we just wrote. So Sr. And then chloride isn't actually an element, but it comes from the element what? Chlorine. So that's going to be Cl. And from here, this is where you need to look up their oxidation numbers or their charges from your periodic table. So on my periodic table, strontium we already found. It's right here in group 2. It's an alkaline earth metal. Not how many valence electrons? What is its oxidation number?
2.
+2. Because it's positive, that's why it came first in my compound. And then chlorine over here has an oxidation number of -1. Perfect. And then a refresher on how we put these together in a compound is that this 1 tells me that I need just 1 strontium atom, and this 2 tells me that I need 2 chlorine atoms. So when I actually write my formula for this compound, it's going to start with my cation, my Sr. Since I only need 1 of them, just writing Sr is sufficient, and it is improper to put a subscript of 1, so we're not going to put the subscript 1 there. And then after that, I put Cl, and I need 2 of them, so 2. Sr, Cl2. And then next, our last example we'll do on this section is potassium chloride. Potassium is my metal with the symbol K. And then I have chloride again, so hopefully you recognize that's from chlorine. What is potassium's oxidation number? +1. And chlorine is -1. So if you have a +1 and a -1, this tells me that I need 1 potassium and 1 chlorine. So then your formula is just KCl.